Okay, so this video is to showcase one of the very newest software by AlgoSurge called OrthoOncoAI. It's an AI-based software to plan tumor-bone surgeries, right? So you open the case, upload the CT scan of the patient. Here's the CT scan I have. So here's only one CT, so I will upload this one. All right, so here's the CT scan, right? And it shows bone very well, and that's the reason you upload CT scan in this kind of software. Now to visualize tumor very well, you can upload MRI of the same patient. So I will just select it. And, all right, so uh, here is the MRI of the same patient. There's a facility here, there are 2-3 facilities here to visualize CT scan with respect to MRI. One is this ghost view. If you click on it, you will actually see a shadow of bone from CT scan on top of MRI, right? Another option to see the CT on MRI is portal view. So this is like a portal through MRI to visualize the CT. So that's why we named it as portal view. So next step is about how to register this MRI with CT scan so that anatomies in both will be on the same position. All you need to do is to select at least 3 landmarks in CT and at least 3 landmarks, 3 corresponding landmarks in MRI, and then just register. Now I need to keep the same 3 landmarks in MRI, right? So go to MRI. Right, so but I think I'm okay with these 3 landmarks and I will try to register it. So I'll click on the landmark based registration button and it will tell me a message and I will just click OK. All right, so if you want to see the registration, something happened and I can see what happened by clicking on this host view. Okay, that's it. Now of course there will be a margin in for the tumor. There will be the tumor visibility will be little different. The boundaries of tumor will be little different, little smaller in CT than MRI. Yeah. Okay, so that's it. So this is the registration. This is the final registration. Now after the registration, we can now create the tumor uh, and the bone from CT and tumor from MRI. You just need to add an object first, name the object, like I'm naming it here as tumor, give it a suitable color, like this one, and then click a button here called make mask. So this is the anatomy you want to segment. And then here you have a brush. With brush you want to draw a mask, which is basically the tumor here, and non-mask, which is basically the part which you don't want. So and you have to do it in 3 slices. All right, so I drawn the mask and non-mask and just click on fill mask button, and within a few seconds you will get a clear tumor boundary. Yeah, this is a tumor segmentation. That's it. Very simple. we have auto segmentation. So if you click on this button, it will ask you which anatomy to select to segment. And so let's select pelvis. We want pelvis here, and just click on segment CT, and within a minute, it will segment the CT scan, and will be shown here in yellow color. So let's just wait for a minute. Okay, so as we can see, within a minute, the software segments the pelvis bone very accurately with all the boundaries intact, and this happened automatically using the AI algorithm. There's a button named 3D here. Just click on that and click OK, and within a few seconds it will create a 3D model of the tumor. All right, so this is the tumor, and we already have a mask for CT, so let's create 3D for the bone segmented in CT. Okay, so we now have the 3D model of both the bone and the tumor with respect to each other. All right, so once you have the 3D models of both bone and tumor, we can use this 3D mesh or 3D model to plan the surgery. You can use this anatomy, plan the surgery on this 3D, and then visualize it intraoperatively using an AR glass. So that is something which we are working on. But you also can design patient-specific guides to make. So here there are multiple options. You choose multi-plane because I think here you can't just make a single cut. PSI, and here's guide, right? Now this guide doesn't have a slot, so you can use the guide like this, or you can have a slot. So you can click on this button called cut slot, and now you have a slotted guide. Okay, so now if I want to attach a plate to this cutting guide, a plate which will, go to more surface of the bone to anchor it well, I can do that, right? So yeah, that's it. So this is basically telling you where the cutting plane in each slice and where the guide in each slice with respect to the tumor, right? So that's a very good analysis before you finalize the design. You need to analyze whether the cutting plane is not too close to the tumor boundary. So that's it. You can 3D print this. You can download this and 3D print and use it in surgery directly. Now this PSI thing is still under development. A lot to be done to make clean mesh out of it, and more design parameters and design ideas will be added to this. Uh, Not only that, we will use this cutting plane plan to guide surgeon intraoperatively using AR glasses. So that is also another project we are doing currently. So that's it. So that's all for the OrthoOnco AI first demo. Hope you like it. And if you have more questions, please reach out to Algo Search. Thank you very much.